Hello, my name is Jack Kim, and this is my Math Criterion C Summative Survey. My topic is gender and glasses. I created a Google Forms survey sent to the grade 9 class of 2020. I gathered the data through Google's spreadsheet. I created two representations of the data. First is a two-way table. Looking at the two-way table, we can notice that there are a total of 50 students who responded to the survey. Among them were 25 males and 25 females. Among the 50, there are 15 who wore glasses and 35 who did not. Another representation is a Venn diagram. I created three sets. Set A is males, Set B is students who wear glasses, Set C is females. Looking at the Venn diagram, we can know that 17 represents the students who are male but do not wear glasses. The 8, which is the intersection between set A and B, represents the 8 students who are males and who wear glasses. The 7 represents the 7 students who wear glasses and are females. The 18 represents the females who do not wear glasses. Determining independence. The mathematical knowledge is a formula: probability of A and B equals probability of A times probability of B. Event A and event B are independent. This means that the two events do not affect each other. I created three events. Event A, selecting a male. Event B, selecting a student who wears glasses. Event C, selecting a female. Probability of event A was 25 out of 50. And probability of event B, was 15 out of 50. Probability of A and B was 8 out of 50, which was selecting a male student who wears glasses. I implemented the formula, and probability of A times probability of B equals 0.15. However, probability of A and B equals 0.16, so therefore the formula does not agree, and thus we can conclude that the two events are not independent. Conditional probability. Probability of B given A means that the probability of event B happening given that event A occurred. This is a conditional probability. The formula is probability of B given A equals probability of A and B over probability of A. In a situation where the two events are independent, probability of A given B equals to probability of A, and probability of B given A equals to probability of B. However, we know that our events are not independent. I came up with three conditional probabilities. First is the probability of selecting a student who wears glasses given that the student is a male. Out of the 25 males, 8 of them wore glasses. The next is probability of selecting a student who is a male given that the student wears glasses. Out of the 15, 8 were male. Probability of B given C, which is probability of selecting a student who wears glasses given that the student is a female. Out of the 25 female, 7 of them wore glasses. What other factors affect the data? In the survey, there are 35 students out of the total 50 who did not wear glasses. However, this does not directly correspond to a better eyesight because there are many students who wear contact lenses, which I did not include as wearing glasses. Considering that many people wear lenses these days, this is something that affected the data. This may be why there is a significant number that does not wear glasses in the survey. Another factor is sports. People who play sports a lot might not wear glasses and rather chose lenses, because wearing glasses are not allowed in sports matches. Thus, the data might be affected by whether they play sports or not. If they play sports, they might not wear glasses. If they don't and have a bad eyesight, they might. Conclusion. After the survey, we know that 50 students responded to the survey, and I conclude that there were only 15 students who wore glasses, which was less than half. The difference between the students who wore glasses and who did not was 20. This means that there are not many students who wear glasses. Another conclusion is that among the 15 students who wore glasses, 8 were males and 7 were females. Therefore, it is hard to conclude which gender has a lower eyesight. Thank you for listening.